All right, so now for the math stuff. You know this was coming. We're going to talk about how to solve these problems, and they can be a little confusing, but only if you don't pay attention to what I'm about to tell you. So check it out. There's a few steps we need to follow, and some of them are slightly different with this stuff. First thing we need to do with this problem is it's really important to draw a picture of these problems. It wasn't a bad idea for anything we've talked about, but especially with these, we've got some direction changes that might be happening, which means that momentum might be negative or positive because momentum is a vector since velocity is part of it. So we always draw a picture of the problem to make sure we understand what's going on. You'll see that. And we're always going to use the guess method. We always use the guess method. It's always good to identify your givens, unknowns, etc. Make sure you're using the guess method. We're going to identify all the information. And again, looking at the picture, don't forget negatives. If anything is moving in a negative direction, left or down, it has to be negative. Really important part right here, when we use the impulse momentum theorem, we're going to start with the full four-part equation. Remember, it's a big equation. There's four parts of it. We got to start with the whole thing, and then we're going to whittle it down to the two parts that we need. There's only ever going to be two parts. Don't use one, don't use three, don't use all four. Two parts that you need. And we get those two parts based on what the problem is asking for and what it gives us. We simply get rid of the two parts that we don't need at that point, and then we're going to substitute numbers into it and solve. So a few different things that are going to go on here, but let's go ahead and get started. All right, so these are the kind of problems that you're going to see. I want you to notice, first of all, right now, look at this problem. A 0.4 kilogram football is kicked from a tee with a speed of 12.4 meters per second. What impulse did it receive from the kicker? The first thing I really want you to notice here, and I'll talk about why later, is that this problem only gives you information about one object. So I want you to just notice that all of this stuff we're going to do today is one object. These are one object problems. A 0.4 kilogram football kicked from a tee with a speed of 12.4 meters per second. I'm going to simply draw a picture first. Here's our football sitting on the tee. It gets kicked. Now, the reason it's good to draw a picture is so there are some things that are going on here that might be hard to notice if you don't. And that is that the initial velocity of the ball is 0. It's sitting on the tee. It's at rest. And then it's kicked with a speed of 12.4 meters per second. It doesn't start out at a speed of 12.4 meters per second, in other words. So that's the picture that we're going to draw. Let's go ahead and define the things that this problem gives us. We know the mass is 0.4. We know that what we just defined right here, the VF is 12.4 and the VI is 0. And it's really important to recognize this, and you'll notice that there's nothing in this problem that says VI is 0. You have to really think about what's going on here. I will tell you, if there is one speed in any of these problems, there has to be two. There has to be two speed because these are momentum changes because the speed is changing. So they give us the mass and both speeds, and we want to know the impulse, which is J. That's what we want to know. Now, as far as the equation goes, here we go. We are going to start with the entire big, long, four-part equation, the impulse momentum theorem, which is J equals Ft equals delta P equals mass times VF minus VI. That might seem like a little overkill to you, but you don't want to miss something that you need. Now, again, we do not need all four parts of this. We only need two. We only need two parts. So before we substitute and solve, we got to pick out which two parts we need. And those two parts are based on the first two steps of the problem. What do they want? And what do they give you? Well, they want J. So I definitely have to have this J part of the equation. And they give me mass and two velocities. That's over here. So I'm going to pick that equation. These are the two parts of the equation that I need, which means for this particular problem, not with all problems, I don't need this and I don't need this. I'm going to get rid of it. So now I've cut my equation down to J equals M times VF minus VI. And this is really important because it's a four-part equation. Since A is equal to B is equal to C is equal to D, then we can use any two parts of this equation we want. It does not matter. You can use literally any two parts of this equation, but two and only two. So now we're going to substitute numbers into this. J equals mass is 0.4, final velocity is 12.4, initial velocity is 0. We're going to take care of what's inside the parentheses first, the mathematical operation inside the parentheses, which is really easy in this case. 12.4 minus 0 is 12.4. Now all I'm going to do is multiply 12.4 by 0.4, and I get 4.96. The impulse here is 4.96 or 5, and the unit for that is newtons times seconds. Newton seconds. All right, here's another one. It's about a tennis ball traveling at 12.2 meters per second. Once again, I want you to notice how many objects. Now, some people say, well, there's a racket in this problem too. Yes, there is, but we have no information about this racket. We only have information about the tennis ball. There's its mass. Really, you can go off of how many masses the problem gives you. There's one mass in this problem. So let's go ahead and draw the picture first. We have a tennis ball traveling at 12.2 meters per second. I'm going to assume that ball is moving to the right, since it doesn't say otherwise. That's what's happening right now at the very beginning of the problem, so I'm going to call that my VI. It is hit by a racket, and its return speed is 14.2 meters per second. Now we got to be careful here because return speed means, here we go, it's going back the other direction. So now my VF is not 14.2 meters per second. If you write this down, that means the ball keeps going in the same direction. It doesn't. It goes in the opposite direction. This is negative, has to be negative. 14.2 meters per second has to be negative. Maybe I should zoom in on this picture real quick for you. So the ball is moving at 12.2 meters per second, gets hit by a racket, comes back at 14.2, but it's negative because it's moving to the left. If the ball is in contact with the racket for 0.012 seconds, how much force was applied? All right, so now we drew our picture, and I'm hoping that you're seeing right now the reason why it was so important to draw that picture is because of the direction change. Be real careful about direction changes. So let's look at our givens now. The problem gives us our VI, which is 12.2. It gives us our VF, which is negative 14.2. Again, be really careful about negatives. Problem also gives us our time. Time cannot be negative. It's always positive because it's a scalar, 0.012 seconds. We also know the mass of the tennis ball. I should have put that first. Doesn't matter though. The mass is 0.25 kilograms. That's all the information that we have in this problem. The unknown that they're asking for is force. How much force was applied? All right, now we go with the equation step. Remember, when it's a one object problem, we start with J equals FT equals delta P equals M times VF minus VI. I'm not going to need all that, but I got to pick out the two parts that I do need. Starting with what they ask for. They ask for force. That's in this part of the equation. Now I'm going to use the whole thing. I can't pick and choose certain parts. I've got to choose that whole expression. The other part's based on what they give me. They give me mass and velocities, which is right here. So in this problem, I'm going to use these two parts of the equation and get rid of J and delta P. Don't need those. Now we can substitute the numbers in and solve. I'm looking for the force, so I'm going to leave that the way it is. Time is 0.012. Mass 0.25. Final velocity is negative 14.2 minus the initial velocity of 12.2. Zoom in on that a little bit for you so you can see how we're substituting those numbers. If the velocity is negative, it's got to go into the equation as negative, regardless of this minus. This minus is just a part of the equation. It's got to stay there. So our final velocity is negative 14.2. It's got to go in as negative here. All right, so now let's clean this up a bit. PEMDAS says I need to fix what's inside here first. Negative 14.2 minus 12.2 is the operation we need to do. Going to end up with a big negative number, negative 26.4. So we can lengthen this out a little bit. That's okay. We still got this 0.25 here. We got negative 26.4 inside that parentheses. Now I'm going to take that negative 26.4, multiply by the mass, 0.25, and we get negative 6.6. And now what's left to do to solve for f is to divide by the time, 0.012. And we get negative 550. Now let's ask ourselves, is it okay that we got a negative force? Well, yes, it is. Force has a direction, remember? And if the ball is going to go back to the left, the force that caused it to change its momentum had to be applied leftward, to the left. So since the force had to be applied to the left, we should expect to get a negative force, and we did. Okay, I want you to look at this last problem on your own. I want you to at least start it. Go ahead and pause the video, read the problem, take the steps that we've been taking, and see if you can solve this problem. Okay, we've got a rider on a motorcycle traveling at 5 meters per second. That's the initial speed. That's what's happening first. And he or she simply slows down to a different speed, to 20 meters per second. So we're not changing directions in this one. We're simply slowing down while going in the same direction. So that's a good thing. We don't have any direction changes to worry about. The givens, we've already said that the VI is 45 meters per second and the VF is 20. It tells us that this slowdown happens in 2.5 seconds, so that's my time. And then it gives us the force. The brakes apply 5,000 newtons of force. Now, really, really important. Check this out right here. Put a star on your page. There isn't a direction change. However, we need to think about this force that's required to change the speed of this motorcycle. Because if the motorcycle is moving to the left and it's going to slow down, the force applied must be directed. Sorry, motorcycle is moving to the right. Force applied must be to the left. It's got to be a leftward force to slow that down. So I'm going to put this force in as negative. It's really important that we see that. So always think about direction. This force is not positive. If it was a positive force, motorcycle would speed up. What is the question asking us to find? Calculate the mass of the rider and the motorcycle together. So same sequence of steps. Let's look at the big long equation first in order to pick out the two parts that we need and then chunk the two parts that we don't need. Problem's asking for mass. That's within this, so we got to keep that whole part of the equation. And then based on what they've given us, the two speeds, which are in here already, and then the force and the time, we're going to go with Ft. Don't need delta P, don't need J on this one. Again, any two parts of the equation. We can use any two parts based on what they're asking for and what they give us. Force times time, masses and velocities. Let's substitute in. First is negative 5,000. The time is 2.5. Mass is what we're trying to find. I'm going to leave that the way it is. The final velocity is 20. The initial velocity is 45. All right, let's clear some things up here. Let's go ahead and multiply these two to simplify the left side. 5,000 times 2.5. I'm just not going to put that negative into my calculator because I know the answer is going to be negative 12,500. I'm going to put the negative in here myself. 12,500 equals, now I'm going to take care of what's inside this parentheses. 20 minus 45, which you probably don't need a calculator to do. It's negative 25. lose 25 meters per second of speed. Now to solve for mass, I'm going to divide by the negative 25 on both sides. Negative divided by a negative is going to be a positive, so I'm not going to put those negatives into the calculator. 12,500 divided by 25. 500. The mass combined of this rider and the motorcycle is 500 kilograms.